have some stuff done though.
Yeah, no, I'm like, Mom, my stomach hurts. She's like, I have Crohn's, I've had it for my entire life. You don't know what a stomach ache is, and I'm like, okay.
Okay, my mom's rule of thumb was if you're throwing up, you can miss school, but otherwise you gotta do it. Alright, welcome Jamie. Alright, you didn't have any homework besides completing the lab, so please email it to me as soon as possible for it. So, gentlemen, we're gonna go ahead and start, we'll review a little bit for it, so we can play the dart game as long as we still move quickly. So do y'all still wanna play it, or are y'all sick of it yet? Okay.
I like darts.
We're still in the dark end of the day.
Okay, as long as y'all aren't sick of it yet. Alright.
I'll never get sick of talking to you. That's fine.
Alright, so thinking back over it, what type of shape is this? We'll start with, I think start with Ethan yesterday.
No, we start with this.
Start with Chris yesterday? Okay, Ethan,
Start
let's
with
go.
the
What?
Start with the
Okay, 4 atoms bonded to a central one. Tetrahedral, now slide it to the top. Don't forget about Jamie. Choose your die. Go ahead and get rid of my slide for junior high.
I told you I was going to quit.
Alright, what is this? Oh, I'm short. What is this shape? It's your turn. Quit studying.
Trigonal pyramidal.
Pyramidal, good job. Just slide down a little bit.
Wait.
Oh, I'm short. Okay.
We know.
I know. Everybody knows. I'm aware of it.
Why did she know I got there?
Okay, now you are. Alright, what is the name for this shape? Quentin, are you still studying or do you want what? Or do you want to study? You sure? Alright, what's the name for this shape?
Thank you.
Good job.
What if I actually accidentally used it?
You cannot be looked at anymore.
I think I have to be expelled.
Be banned from playing this game. Good job, Quentin. I'm sorry, Quentin.
You will 17 phone call.
That is number 17.
You dropped
I did. Alright,
the angular.
Ethan's turn. What's this one?
I got away.
Good job.
Trigonal 9/11 plane here.
Okay, make sure you don't get distracted. Oh! 12. Alright, what is this one's shape, Chris?
Linear.
Linear.
Is linear polar or not?
That's coming next.
Brett.
Alright, so for this one, typically polar or non-polar?
Or both.
Yours, I believe, because we're doing them on
Or
our circle.
both.
Or both. It can be both, depending on how it's bonded. I mean, one or the other. It can be both simultaneously.
It's gonna go down.
Ooh, good job. Alright.
21.
Polar, or I'm just gonna say both, because most stuff isn't non-polar all the time. So polar or both?
Me?
Yeah.
Both.
Oh, it is Ethan. I'm so sorry.
I was gonna say both.
I get.
I was. I really
Okay,
was.
I'll let you have it. Technically, it is Ethan's turn. Your next one will be easier too. Okay.
They're
It is.
both.
It is both.
I
Oh,
know.
oh, hang on. Sorry, I forgot. Really, I forgot which one's holding up. So this one. So, is it almost always polar or both?
Never say never.
Because remember, there's 2 regions of delocalized electrons.
Almost always full.
It's almost always polar. There you go.
Nice.
I forgot which one I was holding up. Alright. So, polar or both?
Both.
Both, because of the reason delocalized electrons.
I can't listen when this man's over here.
Alright. Polar or both?
Not a few words in the same. Oh.
Both. Because it can be polar or non-polar. No
They can see me.
Oh, no, that's my screen up here. Yeah. Get up.
Did they see me?
I think they saw that you're over there. Okay, not too hard. I have Jen's on board. 17.
It's not.
Alright.
I feel bad for the teacher who gets this room after you.
And they're gonna be like, where's my chalkboard? Don't worry about it.
Or by the time that you get a new by the time you leave, they'll probably have a new chalkboard.
Yeah, probably will. Alright, so what is the main reason why this one's
It's my turn technically.
It's my turn, it goes after.
Why is this one almost always polar, but this one's typically not, or can be both? Why?
Because of the unpaired electrons on the tetrahedral, no, the trigonal.
You know,
Yeah,
so for
unpaired.
this one is symmetrical if it's the same all the way around. Yeah, you can see this right.
And that one's
This one's asymmetrical. Okay.
So are we gonna review this, he's gonna take the quiz, and then we're gonna do terms after that?
We're gonna finish up talking about material stuff, and
You think we'll have
then
time to review at the end?
probably we're gonna start. I'm gonna get you a head start for your homework for Thursday, because you have a bunch of homework for Thursday to get you ready for your test.
Like how, wait, what's our test is not this week, is it? So wait, how much homework are we talking?
Like a lot.
Like more than 30 minutes worth?
Depends how fast you work.
Like for me?
Possibly. That's why we're starting a little bit today.
So I won't be able to finish everything in 30 also, what you're saying?
That's okay. I'm giving you
We don't
time
have to go with
today,
that.
and whenever you don't
We don't have
finish
to go.
up, it's homework tomorrow. So that's the reason why we're starting it today early.
Can I do my plane geometry?
No, because this is chemistry class. Alright, so what is, alright, thinking about the molecular forces, I think I've covered, oh, what do we call it whenever I draw it on the board? What do we call it, type of diagram?
Fluid structure.
Fluid structure.
Oh.
Okay, no, because you're gonna hit it, and it's not. Very nice throw. I'm sorry.
Very
Alright,
nice
what
though.
do we call it whenever, what do we call all the electrons whenever they're not locked in? You love the eyes, come through.
Guess what I know? Good luck on PlayStation. I would actually break your iPad.
Yeah, we don't do that.
Actually, it wouldn't break your iPad, it would just like cause a graphical error.
I'm sorry, Clinton. Ooh,
What the world? That's 15.
That's 15.
That's 15.
it is 15.
We all 15. Sorry, I'm 18.
Alright, what do we call the situation whenever you have the electrons are being shared by more than one type of substance?
Here, left annihilation.
Delocalization.
Ooh.
What the
You
world?
just whip down there. Alright, so what do we call the forces that make one molecule be attracted to another molecule?
Start with an O.
There's an I.
Intermolecular forces.
Molecular forces. There are 3 different types of molecular forces.
That's a big one. I don't think it.
Like, what are you doing? Where's my dice? Sorry.
Christian's like throwing darts, so don't care if I get
I really don't. I just like throwing darts. I wish they were well darts, so I could throw them in your hand. That's okay.
Alright, what type of force is the weakest force? London.
Give me my pen back. Thank you.
Depression. Anxiety.
Ooh.
That's predominantly too.
Alright, what force is between all molecules? London. Between polar and non-polar.
Hey, forget about Birmingham forces though. London, Birmingham, England. Birmingham, England.
You're not getting too distracted. I
Boom,
don't know what's happening over there. Alright, what force is also in
Dipole,
polar?
dipole.
Yes. Polar molecules.
What was the question?
What force is also in polar molecules? So London's there, but then also polar is there, and polar is stronger. Not too hard, you're gonna get banned. You're about to get banned for real, because I can't have you denting my stuff. Alright, what is the strongest type of intermolecular force?
It's going.
Starts with an H.
They want me banned because they know I'm a better dart thrower than them.
Alright. Alright, we'll just go to Ethan next, because there's only 3 of you.
Hydrogen bond.
It is hydrogen bond.
Hydrogen bond or bomb?
Bond.
I said that yesterday and I almost got it wrong. Because I said I just said hydrogen.
It's not just hydrogen, hydrogen bond.
I knew that was not.
I'm very sorry, Ethan. I'm very sorry.
That was on 25 and this was like.
An inside joke.
Come on! That was 29! That's 16, but.
Yeah, it is 16.
Yeah, I landed right here and it was like, okay.
Alright, which force? No, I said, this is which force is the strongest. What is
Oxygen.
And
Hydrogen, what?
oxygen, there's two others.
Carbon?
Oxygen, what's the other one start? Fluorine.
Good job. Your last one?
What's the other one start with?
N.
Nitrogen.
Nitrogen. This is your final warning though. Otherwise you can't find one. Alright, there are two different types of solids based on their structures. What is one that has an ordered arrangement? This line.
Yeah.
That was officially broken now.
Good throw.
Dude, I got 25 the other day. You messed it up.
Alright,
That's one.
Ethan's turn. Alright, Ethan, what is the other one that doesn't have crystalline or doesn't have that ordered arrangement?
First, amorphous.
You're just, yeah, amorphous.
This man said Pokemon Emperors. That's actually a Pokemon.
Good job.
It's like, it's like
Alright, what is the simplest repeating unit in a crystal cell?
Unit cell.
Good unit cell.
Would probably be, yeah. That's some good numbers, but I thought it was
That was a good toss. That was a good try, but it wasn't too hard, so just be careful. Alright, what do we call the simplest crystal system? I'm not sure what happened over there. It starts with C. C. It's basically what dice are. Cubic. I'm sorry.
He got that and Ethan couldn't even get it yesterday.
Yeah, 'cause she didn't show me the dice.
Yeah, she did actually.
No, she didn't.
She said,
No, she
it's
didn't.
the same thing as a dice.
Yeah, that helped a lot.
I'm sorry, Quentin. Alright, so we started with Ethan, so we'll go ahead and we'll stop there.
Oh,
Alright,
come on.
who has 30 or more?
I had it. I know that. But
Alright, who's got 40 or more? 50 or
Chris.
more?
You don't know you.
Chris?
I have 50
Real?
or more.
Alright, 60 or more. 70 or more. 80 or more. Chris, feel like you're laughing. How many points do you have?
9.
Alright, Quentin wins. Alright, Quentin, you got any questions?
Stupid.
Can you take your quiz?
No.
Alright, bye.
Are we just gonna be quiet?
It's not that hard.
No, we're just gonna send him to Mr. Jasper.
that's how chances real quick.
Yeah,
It's only
yeah,
gonna
for
take
the
you
animal.
40 seconds.
So the last question, yeah, I'm just
No. Forgot
It'll
to
take me
write
like
it
1 minute.
Can we get our quiz after we leave?
down. Yeah, and we'll talk through it super quick. We're gonna make sure Quentin actually leaves and that he's not just working outside the door.
I'll just go out there and stand by.
I'll let you cut.
I'll tell you.
Now keep in mind, because I'm recording, we can't go over the answers directly, but we'll go through and we'll explain them. I think that'll help you out. Alright. Alright. Bye, Quentin.
There's a bag.
There's a back, yes, there's a front and back. So there's a front and back to this one.
It's that exam.
Gotta make sure Quentin leaves. Alright, so we can't go over the answers directly, but I think if I re-explain something, I think that'll help you out for it. Alright, let me.
Wait, 60 about that, just a little bit.
Alright, so for this one, so to re-explain, whoop. Sorry.
No, no.
Alright, so
Yeah,
to
you're right.
re-explain it, why, thinking about it, almost forgot about Jamie. Alright, why would this one be considered polar, Ethan?
Because of the unpaired electrons.
Yeah, and why is this one not polar?
Because it doesn't have any unpaired electrons.
So this one is symmetrical, this one is asymmetrical. So it's not focusing on the optic rule, it's focusing on, okay, are they paired or are they symmetrical or are they not paired symmetrical? So I think that might help you out for it. If you still have questions about it, we can talk about it later after class for it. But that's the reason why it boils down to, do they have a polar and a non-polar region?
On
That's
number
how
10,
that's
does me not make sense?
we can't go over the answers directly again because I'm recording, so we can't go over all the
That's such a
answers.
boring answer.
We can't go over all the answers. So again, because I'm recording, we can't do it right now for it because I haven't gotten Jamie's quiz yet. So again, please continue as soon as you can. So because of that, we can't go over all the different answers. So just make sure that helps you to explain it for it. Alright, again, we'll talk about it at the end of class for you. Alright, so turn over to page 145. So this is where we left off. We watched the video over this because it makes so much more sense if you watch the video for it. What?
Give me this back.
I mean, if you have a question about it, don't throw it away. So that way we can go over it. Alright, so page 145 talking about clothes packing and how to pack them into a smallest amount of space for it. Your book's trying to show you, but again, watching the video is so much easier at
Don't
that
we need to
point.
turn in
for
our
it.
lab?
What?
Don't we need to turn in our
That
lab?
is right, you do. Thank you. Go ahead and take it out in the lab. I knew I was forgetting something. Go ahead, take it out, tear it out. What?
Do I get candy?
You want a piece of candy for my
Nice.
I got $1 then, cause I looked up answers.
What?
In English.
Alright, so go ahead and tear that out, tear it in as well for me. So it's really hard for me to demonstrate that lab since I don't have the foam, because I don't have the foam material on the inside of it. But did it not come out well?
That's all I do right here. You
Oh.
graded it, right?
Yep,
Wait, where are they for?
don't lose them.
Where are they for?
Find out in a minute.
Oh,
Oh.
It's not in there, you can still, yeah.
I can't.
I don't understand, my paper never rips right. So obviously you use your air. Yeah, are these to blow our noses?
No, just hang on to them for a second. Alright, so we're talking about different types of crystal arrangements or with different types of cubic structures. So what would be a simple cubic, Ethan?
crystalline.
Okay, it's a type of crystal. So if I'm talking about a cubic structure, what would be the simplest type of cubic structure?
A cube.
Alright, so describe it. How many molecules could I fit in it?
8.
Good job. Alright, so if I have a body-centered cube, how many molecules could I fit in that one, Chris?
12.
Sure?
Yes.
For a body-centered one?
Yes.
Sure. Look at the top of the page, count. 9. There you go. 9. Welcome back.
That was quick.
Alright, and then for the
Easy
last
quiz.
one, for the face-centered one, how many molecules could I fit in that one? Ethan,
Page 145.
In what?
the face-centered one, where it's one in each face.
Take 12?
12 all together for it. So, which one has the most molecules in the smallest amount of space? Ethan,
Face and cube.
good job. That one has a face-centered one for it. Alright, we also watched yesterday in the lab, so we'll have to talk about for you because you watched the lab yesterday for it, so we'll talk about what you can do for it. Alright, so close packing, this
I'll
is
give you
another
that.
category for it. So, close packing, your book points out one of the most efficient crystal structures is hexagonal close packing. Alright, if it's a hexagon, how many is it going to be touching each other and then have one in the center? But how many are on the outside touching each other? Chris?
Five.
Okay,
6.
good job. So 6, that's what it's showing you the bottom page on page 145. That there's 3 on one side, 3 in the other. So that's where like the name hexagon's coming from, and then there's 1 in the center for it. So for those, hexagon close packing is another very tight type of packing as well for it. So those two, the body-centered, the face-centered cubic and the hexagonal close packing are considered the most compact types for it. So make a note of that on page 145 in that second full paragraph for it, that the face-centered cubic or the FCC and the hexagonal close packing ones, these allow 12 identical neighbors for each atom, and so because of that, they're considered the most compact type of packing. So whenever you pack a suitcase, we talked about this yesterday, if you weren't here. Do you just throw things in willy-nilly, or do you actually pack it? Throw it in willy-nilly? Okay, so you can just throw things in willy-nilly, that works, but how does your mom pack? Does she pack everything meticulously in the suitcase? Okay, that's because typically ladies want to try to fit as much as possible into a smaller space, but that's one of the reasons why they will go through and organize everything. But you can also just throw things in willy-nilly, and that works too for it. Alright, anyone have any questions about that? Alright, so we watched the lab over part of this yesterday, and I don't have the foam for it, so we can't build the models exactly. But then I remembered, I do have marshmallows. And marshmallows and toothpicks also work off the same idea. So again,
Snack
they're
time!
all marshmallows. We can't spend too long on this because again I gotta talk about it on the next page as well for it. But if you're building a body-centered type, well first of all, if you're building a simple cube, how many marshmallows do you need?
8.
Good job.
Quick.
I may have Grimex on them. You can voluntarily choose to not keep the marshmallows later. What you're gonna need.
I'll just give one of mine.
You need how many? The 8 lines, right?
Yeah.
7, 8. So we're having a little bit of time. If I give them to you now, are you gonna get distracted by your marshmallows? 3, 4, 5, 6.
Make it 9.
You need 12 lines? Yep. Count, let's see, 5, 6, 7, 8, 9, 10, 11, 12.
Can I get one more?
Maybe again. Are you gonna use that as a shank?
No, just for you know. Yeah, too quick.
If I see this being distracted, I'm taking it back.
I'm not.
Can I get that too?
You may have to.
I don't like the number 12.
Are you gonna be distracted with it?
No, I just really don't like the number 12.
Okay. But if I see it being used as a shank later, I'm taking it.
Yeah.
1, 2, 3, 4, 5, 6, 7, 8,
Never
9,
give
10,
them their
11, 12, 13. I'm gonna try to not touch your marshmallows.
I got 14.
Oops.
Visionary.
Used as a shank, I'm taking it back. 1, 2, 3.
Whenever I'm at my grandparents' house, I eat a whole bag of these in a day.
1, 2, 3, 4, 5, 6, 7, 8. Oh, you get 9 by accident.
What are you building?
Simple cube.
What does that look like?
How many marshmallows?
I have it.
Okay.
Did we start it?
You can go. A
Sorry.
little bit of extra time. Sorry, Jamie.
That's what we're doing for the rest of class?
No,
Oh,
we
man.
gotta learn stuff too.
That's whack.
Jamie is really jealous right now.
There's stuff. How many marshmallows is that? 6.
So how do you make?
Let's say Ethan! Oh, you get one extra. Don't eat yet. We'll eat in a minute. Sorry, Jamie.
She ain't sorry.
Ran
Amy.
death. Oh no.
You can build them at home if you have marshmallows.
Yeah, like she wants to do that.
You can also fast forward if you want.
I would probably do that if I was doing virtual. I do it all the time. I skipped an important part, so I did. I really did. I was not what I was doing. I really did. I promise. I watched the video to make this, but sometimes like I skip the review sometimes because I just
As long as you got it.
like one time I had to go and I was like I need to finish the video real quick.
How to go do what?
Go eat lunch. So I was like I finished this video before I go.
had to go eat lunch.
Yes, I had to. I went and ate actually that day. I had that like yesterday.
Jamie, you probably do want to fast forward. This is gonna take a minute. Chris, don't use marshmallows yet. You're gonna need them in a second.
This man said that. Are we done with marshmallows?
Not quite yet. Alright, let's give everyone's room
I'm done.
Alright, if you were to have a body-centered cubic, what does that one have to do? What do you have to do for that one?
Same thing, just put one in the middle.
Yep, so take your extra marshmallow if you have an extra marshmallow. If you don't have that extra marshmallow, I'm sorry, I'll give you your extra marshmallow. And then shove it in the center. Yeet.
How are we supposed to shove it in the center?
Yeah.
Do you need an extra toothpick? Sometimes, depending on how you struck it and how you built it, you might could just shove it in the center and call it a day. But if you need an
Have
extra
another
toothpick,
toothpick.
my hand, they're still, we'll give you 2 extra. Again, do not use them as shanks.
Why not?
I don't think there was one mine shoot.
So depending on how creative you are, you might can get away with it.
There you go. It's in the middle now.
Yay! Alright, so let's buy
What do you
one.
want my house?
Alright, and if you have a face-centered cubic, how many would you need for that?
12.
Well, yes, for 12 for it, so you have 9 right now? 1, 2, 3.
We don't
I
have
think I have what?
enough.
No, I don't have enough marshmallows for everybody. Okay. Alright, so you can go ahead and keep your cube off to the side though, so it can stay on your desk as long as you don't get distracted by it. But if it becomes distracting, you can put it off to the side later. Just
So it's gonna sit there, we can't eat it?
You can eat it at lunch. Maybe if we have time at the end of class and we can start on the classwork or the early homework, you can eat it then. Alright, welcome back, Jamie. Come back to the video if you fast forwarded. Alright, it's really ominous hearing all the hand rubbing and like medical fast. Alright, look over to page 146. Just talking about crystals and cooking. How many of you, your mom is going to be making like fudge, and other things for like Christmas coming up?
We don't celebrate Christmas.
Probably not.
I celebrate.
I don't celebrate
holidays.
Oh, okay.
I
Alright, so
celebrate,
let's
I
read
celebrate
through it.
Chinese New Year's.
Alright, so look over on page 146. So crystals and cooking. Who wants to read first? There's, as you can tell, there's a lot. There's a lot of them.
Cookies and cooking.
No, crystals and cooking.
I'll read.
Ethan, we let you go
You
first.
scared me.
60 seconds.
Why'd you let the slow reader read?
You volunteer first.
146.
Right there.
Why that four?
I just read the whole thing and they can read the rest. Alright. Controlling the size of crystals is important for creamy texture and a number of confections and desserts. Cooking icings and fudge, for example, contain relatively high concentrations of sugar. If they are beaten properly as they cook, small sugar crystals will form, resulting in sweet texture. It is important that the ice crystals that form in frozen desserts be kept small as the desserts are have a smooth texture. Effective stirring of the desserts.
Oh my goodness, say it again.
Desserts!
There you go.
As they freeze introduces air bubbles which interfere with the development of large ice crystals. Substances such as buffer fat, which I have no clue what it is, whole eggs, egg white, gelatin, gums, or
Carrageenan, you got it. Good job.
used in commercial products also help produce a creamy texture by coating the ice crystals, creating a rubber.
Good job. Alright, so this is one reason why you should pay attention, Chris. So this is one reason why if your mom is going to be making like caramel or fudge or certain types of confections over the next couple of weeks, that's reasons why you can't just stick it on the stove and leave it. It'll either burn or it's going to start developing like this grainy texture. So you have to constantly stir it and watch it.
It's like creating, never mind.
Alright, anyone have any questions about that? So again, just something just to notice as the holidays are
It's
occurring.
like making a roux.
Oh what?
A roux.
What's a roux? I
You
actually
know
don't
what a
know.
roux is?
I actually don't, I'm sorry.
Do you cook?
Sometimes.
That's a no.
Yeah.
Do you know what a roux is?
Yeah.
What's a
Yeah,
roux?
she goes out to
We
eat.
like.
Just look it up. Look, no, look, no. Look it up.
No, I'm asking. What's a roux?
Don't answer.
Arabian flour, and it's like.
Oh, okay, yeah, no, I don't make
It's
that
a
too
thing
often.
in Asian.
Yeah.
Yeah, my mom does more of that type of. I like cooking. I like doing baking and stuff more. That's like I'm gonna do like fudge and desserts.
I
and
like,
brownies and
my
stuff.
favorite food to make is Alfredo, so I use a
Yep.
or something.
I love
Alright,
Alfredo.
So, looking over on the next section. So, liquid crystals. Alright, who wants it? Chris or Quentin? Start off with you. Okay, Quentin, volunteer first.
Crystalline solids are characterized by three-dimensional order, whereas liquids have very little, if any, order in their molecules. Some substances, however, retain an organized molecular arrangement in the liquid state, as long as they are not too far above their melting point. Even this order disappears at some higher temperature. But between these two temperatures there is some order. Such substances are liquid crystals, able to move freely in certain directions while retaining a degree of order in others. Liquid crystal molecules typically have long and narrow rigid rod-like structures. Common examples of liquid crystals include soap bubbles, cell membranes, and substances used in the display screens of calculators, computers, and watches.
Yes, we know what a liquid crystal is. It's able to move freely, but it still has order in its system for it. Alright, we'll let Chris have a turn, and then Ethan if you want to.
Alright, you guys wanted M&M, right? Alright.
Hurry, Chris.
You want me to hurry?
Not to make sure you should read it, but I would want you to hurry up and read and not be as dramatic about it. So hurry up and go.
The membranes of living cells are liquid crystals composed.
Okay, now stop and slow down so that Jamie
The
can understand
membranes
you.
of living cells are liquid crystals composed largely of special molecules called phospholipids. Phospholipid molecules have a strong polar head and two nonpolar tails. The head is strongly attracted to water, but the tails are repelled by water. These properties cause phospholipid molecules in water to cluster with their tails together, forming a thin membrane. Although the membrane is liquid rather than solid, the molecules in the membrane are highly ordered, making the membrane a liquid crystal.
Good job. Alright, so for this one, you have the polar head on the outside, and then you have tails towards the inside. And so the membrane is made up of all these parts, layers, over and over again, and that makes up the entire edge of your cell. So that helps out with osmosis of particles on the inside of your cell, so it doesn't all come in and all come out for it. So again, that's a phospholipid, that's an example of a liquid crystal, because that cell membrane, technically it's a liquid, but it has a lot of order for it with how they're aligned for it. It'll come with the idea of a liquid crystal, with the idea of it's freely movable, technically I guess not straightforward liquid, but it's freely movable, but it also has order.
Can I finish
Alright, does anybody else want it?
Can I finish it, cause they got a whole section.
They got a lot of section. Okay, you can go.
Artificial liquid crystals are widely used in digital displays of watches, clocks, calculators, TVs, cell phones, and computers. Such displays using liquid crystals are known as liquid crystal displays or LCDs. In an LCD, a thin layer of the liquid crystal is placed in a small cell between transparent electrodes, glass coated with conductive substance, that are connected to an electrical circuit. The cell is designed so that it ordinarily appears clear. When the electric field is turned on, however, the liquid crystal molecules line up in a way that makes the cell appear dark or opaque. In a high-resolution LCD display, such as the screen of a TV, cell phone, or computer, millions of such cells are arranged in a grid. Applying a voltage to the proper combination of cells allow letters, numbers, and pictures to be formed. Color filters included in the cells allow colors to be displayed as well. In simpler displays, such as those in watches and inexpensive calculators, a small number or much larger cells are arranged in the shape of letters or number segments.
So your calculator, like the black portion of your calculator, that's what's telling it to basically show up or not, or to be that dark color. That's an example of an LCD. On your TV or on your tablet, they have a color grid with it as well, so make sure that it's colors and not just black. Alright, anyone have any questions though about liquid crystals or about that?
We're done with this chapter.
Yep, we are. Anyone have questions though? Alright, so we're gonna go ahead and get you started as we do this class because you have a lot of homework for Thursday, so we're gonna go ahead and let you get started for it. So, Jamie, we probably won't really do anything for the rest of class besides just starting over the classwork. We might go over part of it, so I'll go over the answers with you loosely tomorrow, whatever we get through in class. So, because of that, we'll go ahead and we'll stop for it, and I'll probably go ahead and stop the video as well, Jamie. So, hope you have a good rest of the day, and I'll email you anything if we do anything different. Okay? So, you don't have any homework tonight because of Wednesday, but if you don't finish this, it'll be due tomorrow.